Welcome back to the second part of the morning tutorial. In this part I'm going to cover use case scenarios and deployment options, particularly focusing on performance, availability, security and manageability cases. So the most important question when starting to consider SD-WAN deployment is how to choose the right solution. And this is a question which cannot be answered generically. Of course, there are many sources that can help, like magic quadrants, analyst ideas, vendor documentation, etc. But in the end, it really boils down to adapting to the use case in the right way. So what are the important use case questions to ask in the beginning? There are tenant requirements. For example, what kind of network do you have? Is it like a small, medium-sized enterprise? Is it a large corporation with a small number but very large branch offices? Is it a retail shop with thousands of small shops? Or are you trying to connect mobile workers and home offices? So that's one question. The next question is, what is the desired service offerings? Which kind of VPN options, what level of security needs to be supported? How should the solution connect to the cloud? And when it comes to cloud connectivity, is the cloud business critical? Should all of SD-WAN be centered around cloud, or is it an option? Do you have a public cloud, private cloud, or hybrid cloud setup? Are you looking for a platform as a service, implementation as a service, or software as a service? So is it necessary to include a cloud broker or not? And finally, which underlay technologies are available? This depends on the locations of the endpoints. Are you looking for MPLS as the very trustworthy, high available solution, or are you looking for low-cost internet? Do you need broadband access for consumer type access in certain locations? Or are you resolving to LTE and 5G as a backup? So this already creates a big sheet of questions, but then the next one comes up. So independent of these use case adaptations, it's an important question whether to start buying an SD-WAN solution, buying the underlay connections separately, starting to operate it, skill up the internal teams to really run the SD-WAN solution, or whether to outsource everything to a managed service provider. Around a little bit less than half of all the SD-WAN deployments these days are managed services, which means a lot of enterprises are finding good reasons to go with their own solution, but there is a tendency, of course, like always, to outsource them. Now, outsourcing is not a uniform market there, so there are many different types of offerings, and to understand them, I've put together this table here, which explains first the differences between do-it-yourself and managed services, and then also allows maybe to ask to interview each potential provider, like what are they actually doing in which way. So solution planning, of course, is a burden of the enterprise if the solution is built by yourselves. The monitoring can be done by the enterprise or together between enterprise and service provider in a co-managed model, or only exclusively by the service provider. So these are generally two types of services: co-managed service, where there is visibility and some part of control by the enterprise, or a fully managed service, which is kind of a turnkey solution where the service provider really takes care of everything. On the provisioning side, of course, the question is how many different options of provisioning are required. So in a co-managed service, typically the enterprise provisions based on a zero-touch system, based on templates. The enterprise may or may not have to do with shipping individual units to new endpoints. And in a fully managed service, of course, the service provider itself would take care of the provisioning. There are aspects which definitely are outsourced in a managed services environment. These are upstream connectivity, like underlay connectivity, and the vendor selection, of course. And when it comes to configuration options of the vendor solution, again, it's quite a big difference. So we have seen a solution from one of the vendors we tested, which has a wide variety of choices. And then when we tested the same hardware in a managed services environment, we were quite surprised that the number of choices were reduced greatly. Of course, the operator will typically work with templates to reduce the amount of complexity, but that also reduces the amount of choices by the individual enterprise. And finally, when it comes to contracts, of course, it's important to understand, are you ready to contract each of the underlays separately, or do you want to offload this to the service provider as well? Continuing the table, one of the questions is also the investment. CapEx is not that huge because the endpoints are normally not that highly priced, but depending on the size of the network, CapEx for an enterprise build SD-WAN solution can be a point of consideration. Whereas for a service provider environment, usually it's a subscription model, of course, and it starts with a low investment and of course piles up all the operational expenses. One of the most important points is probably what skill sets are required, and I'll cover that in one of the coming slides in more detail. But there are different options also for the managed services. In some cases, level 1 support, like basic connectivity, can optionally be provided by in-house staff, and level 2 support can be outsourced to the operator. But of course, it's also possible to fully provide this as a managed service. Let's get back to the security options later. And finally, the integration into business processes and automation, so the integration in the enterprise processes, is also an interesting question. For large corporations, this might be a very decisive factor, whether it's possible to integrate with an OSS or not. And naturally, the choices are more open if the vendor solution is built by the enterprise itself. On the operational challenges, one of the major questions is the skill set. In principle, SD-WAN should be simpler to operate than traditional VPNs from the MPLS era, for example. However, with the additional complexity that has been added in the recent years, there are quite a wide range of different skill sets that are touched upon. It's not only underlay connectivity and overlay connectivity. It's not only VPNs. It's not only security. There are also things like application classification, the whole topic of zero-touch provisioning, and all sorts of different aspects, which are not always easy to acquire. So it's one of the major decisions for an enterprise whether to upskill their internal staff or outsource the solution. The organizational structure is a question as well. So since SD-WAN connects all of the different silos, it's important to have staff that understands the applications as well as the transport. Tools are an important question, since the old traditional tools to manage VPNs or manage applications can no longer be used. Integrated troubleshooting tools are needed to go back to an operational state after a fault has been noticed as quickly as possible. So the operational challenges are not to be underestimated. But one thing to consider is not only the enterprises are challenged by this, also operators. It's an important question to an outsourcing partner, like how have you skilled up your team? How many team members do you have who really understand the whole wealth of these options and the complexity of SD-WAN services? So I would like to add one more slide on managed services, like where is the responsibility going? And we recently compiled this for one of our customers who said, well, outsourcing is easier because I have one face to the customer and I just file a report of a fault and then they will fix it. But if we think about how an operator is organized, typically there are different departments for underlay and for overlay. And in the underlay, there are different departments for layer 1 connectivity, like physical layer, last mile problems, for layer 2, layer 3 problems. On the overlay side, there are different teams for CPE hardware, for SD-WAN configuration, for potentially public cloud connectivity, and for security threats, of course. And we can even drill this further down. So the question is, A, how fast will an operator be able to respond to a problem? And B, who is actually responsible for fixing things? In many cases, these different entities shown here on this slide are not all provided by employees of the same operator. They are often outsourced to partners, to integrators, maybe even to vendors who are white labeling their solution. Outsourcing responsibility is difficult and it requires careful analysis of the individual service provider offering. That's one advice I'd like to give you. Now let's look at the vendors supplying SD-WAN solutions. They all come from different heritages, and this is quite important to understand. Where are their weaknesses, where are their strengths to be expected? So some vendors actually originally manufactured routers. Their strength, of course, is in the transport layer. Some of them came from firewalls. So they will probably start with security aspects, and when evaluating them, it's more important to look at the factors which are not in their home turf. Some vendors are WAN optimizers, so they are naturally very strong in classifying the applications. Some are actually founded as a native SD-WAN company. So I know a handful of vendors who have just been founded for this purpose. They are probably at advantage when it comes to the SD-WAN control and the multipath selection. And finally, there are a few that actually originated as VPN software vendors for remote connectivity. So the strengths and the challenges of each solution are often related to this heritage. And it's important to understand the product to select one that's most suitable for a given use case. Application-specific control, that's probably one of the more important aspects of SD-WAN. So when there are multiple uplinks available, like a low-cost and a higher-cost, smaller bandwidth one, it's important that the edge endpoint can differentiate between the applications. I have not seen a single datasheet that did not promise application-specific classification. However, this is a moving target, and it means different things for different vendors. This is not to blame any vendors, and not always the most expensive solution and the most diverse one is the best, but it's important to understand the differences. So some vendors, at least a few, just say application specific is based on layer 3. That's the cheapest option. You only analyze the IP address. Some of them say they analyze the TCP port. For example, for them, port 443 is a web application, and that's the type of application they see. However, if 99% of your enterprise applications are based on web, then this is not a good classification. The next one is on URLs. So this is, for example, helpful if you want to treat access to a video area on one web server different than access to a, let's say, wiki area on the same web server. Of course, it's also important to understand how well does a solution actually handle encrypted traffic. More than 2/3 of all traffic on the public internet are meanwhile encrypted. And sometimes it's possible to decrypt it inside an enterprise if the private keys are known. Sometimes it's not possible or it's not desirable. And finally, there are layer 7 applications, but on the example of Office 365, for example, it's not sufficient to just understand, oh, this is Office 365. There are big differences, whether we're talking about a Teams call, whether we're talking about collaborative editing, whether we're talking about synchronizing a laptop's content back into the cloud, and etc. So these applications should all be differentiated ideally. A very important topic is security, and I cannot do justice for all the aspects of SD-WAN security in this short tutorial. But let's get the basics. So traditionally in an MPLS VPN scenario, all of the connections, all of the traffic went to a central hub and then from there into the internet. So that worked when internet traffic was only a small amount in an enterprise. That's also possible in SD-WAN, of course. It's also still possible to funnel all of the traffic to a central data center and then have a strong, big firewall between the central hub and the internet. However, in almost all cases, meanwhile, there is a local internet breakout, which means that the edge endpoint in a branch location already selects which traffic goes to the corporate side, which traffic goes to a private cloud, and which traffic goes to a public cloud or to the internet directly. So that means each location is responsible for security, and the strength and weakness of the security function in each separate branch location defines the strength of the security concept as a corporate as a whole. So now it's important to understand which security functions are actually provided by the different vendor solutions, and there are quite vast differences. I would say that the level of security support is probably one of the most differentiating factors in SD-WAN solutions today. Now, of course, you could argue, well, I can add a separate firewall to my solution. I have an SD-WAN plus a firewall, but that's a question we already touched upon in the first part of the tutorial. So first option is a simple firewall. Access control lists, stateful firewall in a traditional way. The second option is a next-gen firewall. I would always suggest to go with a next-gen firewall when connecting to the internet and having an internet breakout directly. And again, there are different functions possible. Whether they are needed or not depends on the individual use case scenario. It's possible to do SSL inspection of web traffic, to validate certificates, to do web filtering. That's probably needed if a web server pool is protected. It's possible to do intrusion detection or protection analysis. It's possible to implement anti-malware, virus filters, or maybe even a sandbox. And as you can guess, the more extensive the security functions, the more the impact on the performance of the CPE and the more expensive the solution in the end. Another class of devices is the cloud firewall. And the cloud firewall and the cloud CPE is typically comparable to the branch CPE, but there are a couple of security specialties. So usually in a cloud scenario, one wants to have the same standard next-gen firewall solutions, plus a secure web gateway, plus a zero-touch network access solution potentially, depending on what level of cloud, specifically for software as a service, is selected. So the security functions need to be chosen carefully, depending on the individual use case scenario as well. Once all of these are selected and there is a clear requirements list and vendors have responded to an RFP, for example, so there are a couple of solutions on the table, and then we would always suggest to run a proper proof of concept test individually. And a proper proof of concept test should be more than just having 2 or 3 endpoints and running pings across them. Because in the real life network, the challenge is also not to run pings. The challenge is to really differentiate applications at scale, at performance, and to provide security at performance. So all of the topics mentioned on the slide are important to look at in the proof of concept scenario from our point of view. At EANTC, we're running many of these proof of concept tests privately, and we find that solutions differentiate most when they're exhibited to real use case scenarios. And in that case, when real traffic is used and there is some relationship between the deployment and the proof of concept, then also the vendors or the managed service providers have the most reason to fix problems that occur during a proof of concept test. So I don't want to go through each of these. I think we've covered upon a couple of them. Resiliency is one topic that I'm not covering this year in the tutorial elsewhere. So resiliency is important, for example, for a highly available hub endpoint. Usually there is dual uplink, and the failover between the dual uplinks, especially when they go to different service provider networks, is a challenging question that needs to be investigated carefully. So to conclude this very short tutorial, SD-WAN definitely continues its success story. I'm very happy to be a part of this and to see the journey going on. The market is maturing, so the number of solutions slowly gets reduced by mergers and acquisitions, which is fine, and the best of breed from different parts of a merger are then taken hopefully into a joint product. What the key decision criteria in 2020 concerns, cloud connectivity and advanced security functions are definitely among them. And that's also great because we see that SD-WAN is developing very complex advanced functions quickly. There is definitely still a big diversity in product and solution choices. Now with more and more service providers coming up with managed services, there's a wide choice for enterprises. That's sometimes painful, but it also is a great opportunity for everybody to find their optimal choice. And now that the Congress has been renamed to SD-WAN and SASE Summit, I would like to add that new concepts such as SASE or SD-Branch are exciting, are certainly also very complex, have a lot of functions to get done right, and from our point of view will take a while before production readiness. In any case, from EANTC's perspective, naturally, because we are an independent test lab, I would always suggest to compare multiple solutions before taking a purchasing and deployment decision. Once that is done, I think SD-WAN has something for everybody because it covers a lot of diverse use case scenarios. We have many different customers, from large enterprises, small government entities and so on, who have surprisingly different requirements for SD-WAN deployments, and they can all be fulfilled. So with that, I'd like to end this tutorial. Thank you very much for your attention.